Hello everyone, this is Thang Nguyen. Today we will go through the forecasting table, and at the end we will draw the two graphs as the following. In the original file, you will see some yellow shaded cells. They contain the equation. I hope that will help you to attempt to fill in the table on your own. Let's attempt the table from scratch. Assume that we already have the actual value data. This column contains the actual values or the AVTs in our equations, and this column contains the corresponding dates of those actual values. First of all, we will need to know the weekdays of the dates. So in the first cell of the weekday column, you will type in weekday parentheses, and you would point to the corresponding date, comma, 2. You might need to try another option if necessary. So I just hit enter. We have a Wednesday, right? And if you drag it down, we have Thursday, Friday, and then go back to Tuesday because on Monday it was a holiday weekend day. And we just double click, then we have the whole column done. Next up, we will need to specify the days in the time window. This column is easy. I just type in 1, 2, 3, right? Because we go from day 1, day 2, day 3, on and on. So I highlight all 3 days together and I drag it out, or I can double click. Then we have the whole column done, right? So the first 3 columns here specify the time frame of our forecasting exercise, and together with the actual data, right? Then these 4 columns are the setup of the whole table. And here is our first forecasting model, the naive model. In this case, we will notify the forecast value for the next day, or FVT plus 1. In this model, we would need to know the day before to find these forecast values, but we do not have that, so I will type in hyphen. But for day 2, we are on day 1 and we can make a forecast for day 2. The forecast for day 2 equals to what we observe on day 1. The forecast on day 3 equals to what we observe on day 2, right? On and on, or you just double click, then we have the whole column filled out. So that's a naive forecast, right? The second forecasting model is a simple moving average model, or SMA. In this model, we have a parameter is a K, and the value here is manually chosen. It says that we need to go 5 days to the past to calculate the average as a forecast value for the next day. So in this column, we need to find the forecast value of the next day based on the simple moving average model. So because we choose K to be 5, we will not be able to forecast for the first 5 days. So I just type in the hyphens, and we can make the forecast for day 6. I would type in equals average, and we highlight the first 5 days. Right, so that's the forecast for day 6 that we make on day 5. And next we can make the forecast for day 7 when we are on day 6. So we would do equals average, and we highlight the next 5 days. Please notice that now the window already moves down by 1 day, and that's why we call it as a moving average. So by now we already have the forecast for day 6 and day 7, and you just double click from here and we have the whole column done. The third forecasting model is a simple exponential smoothing, or SES model. In this model, we have a parameter called alpha. This alpha value is for now manually chosen, and we will need to find the forecast values for the next day, or FVT plus 1 of the SAS model. So these forecast values differ from those of the naive and the SMA model. In this model, we do not have the day before, so for the first day we have to make a very special assumption that the forecast value equals to what we observe on day 1. And for day 2 on, we can use the equation to make the forecast. So for day 2, we would type in equals, click on the alpha and lock it in, times the actual value of the day before plus 1 minus alpha in the parentheses, and of course we need to lock in the alpha one more time, and then we multiply 1 minus alpha with the forecast of the day before. So because of the special assumption on day 1, the values of day 1 and day 2 are exactly equal, but if we try the third day on, we're gonna see the differences. For the third day, we will type in equals the alpha value locked in times with the actual value of the day before plus 1 minus the alpha value locked in one more time, times with the forecast of the day before. And when you hit the enter, we have the forecast values for the third day, and you just either drag it down like this or you double click, right? Then we have all the forecast values by the SAS model. The fourth forecasting model is the double exponential smoothing model. So in this model, there are 2 equations, one for the forecast value itself and the other for the trend forecast. That's why for this DES model, we're gonna have 2 columns. And at the same time, we have 2 parameters, the alpha and the beta. This alpha is separate from the alpha that we got earlier under the SES model, because this DES model is a separate model. So for now, these 2 values are manually chosen, and we would do the forecast values as the following. For the first day, we do not have the day before, so we have to make a very special assumption that the forecast for the first day equals to what we observe on the first day, right? And for the trend forecast, we have to assume that it is 0, which means that we do not have any trend. And on the second day, the forecast value equals the alpha locked in times with the actual value of the day before plus 1 minus alpha also locked in times with the forecast of the day before. And we need to add one more term, which is the trend forecast, right? So this is a forecast value for the second day, and the trend forecast for the second day will be equals, we multiply beta locked in with the current trend, which is the difference between that forecast value minus that forecast value, and then plus with 1 minus beta. Also, we need to lock it in and then multiply with the trend forecast of the day before, right? So for the third day, we'll do something very similar. We just move everything down by 1 day, right? So for the forecast values, we would do equals, click on the alpha, lock that in, and then multiply with the actual value of the day before plus 1 minus alpha, and locked in one more time, and multiply with the forecast value of the day before plus the trend forecast. So on the third day, you're gonna see something different from the first and the second day, right? And for the trend forecast, we also do similarly like before. So equals beta, and we lock it in, and then multiply with the difference between the 2 forecast values. Right, we call that as a current trend. the term in the parentheses is called the current trend, and plus 1 minus beta, locked it into and multiply with the trend forecast of the day before, right? So you can either drag column by column like this, or you can just highlight the two cells like this and double click, then the whole thing will be filled out for you. Sometimes we see positive trend, right? And sometimes we see negative trend. It is okay. So if it is a positive trend, then by itself, the stock price will go up, and if it is a negative trend, then by itself, the stock price tends to go down. So this is a fourth model, right? So there are two equations in this model. That's why we have two columns, and the forecast values are in this column. At this point, I would like to digress a little bit and talk about why we have to lock it in. Let's take the SES as our model. So in this model, we have a parameter, the alpha, right? So the 0.6 here is the 60% weight that we put on the present data, and the remaining 40% weight that we put on the past data. So the percentages have to be fixed in all of the calculation in this column. So if we do not fix the 0.6 here, then the values down here will be wrong if we just drag it down, right? So let me show you a demonstration of what will go wrong if we do not fix it. So first of all, I would like to delete the whole column. Right, on the first day, we just assume that it is equal to what we observe on the first day, right? The forecast equals the observed value. And on the second day, we can click on the alpha times with the actual value of the day before plus 1 minus alpha times with the forecast value of the day before, right? So by itself, this equation is okay. But when we drag it, then all the references will go down row by row when we drag it out, right? So that's why the calculation will be wrong. So if we drag it out like this, right, then you're going to see weird things because we do not fix the reference. Right now, the G7 already become G8, and that's wrong, right? It is not that. It has to be the 0.6 or the G8 right here. We also have to fix it. Otherwise, the reference will be moved out here, which is just takes. It doesn't have any value in it. And there's no guarantee that the value in this cell equal to the 0.6. So that's why we have to lock it in, right? To lock it in, we have to use, and I'm using Windows right now, we have to click on F4 or function F4 if the keyboard lays out that way. So that the goal is we put a dollar signs in that reference, right? Or if you are using Mac, you will need to use a combination Command T to lock it in. So you just put the cursor here and click on Command T in Mac, or click here and click on Command T in Mac. Then you would lock it in. And if you are using an online application, either F4 or Command T doesn't work, then you have to manually enter the dollar signs. To make it easy, just put both of the dollar signs before the letter and also before the number. So after we lock it in, make sure that everything is correct. Then when you double click, everything will be correct because we already fixed the value of alpha. So by now, we already have the forecast values by the four models. To calculate the MIP, we will need to calculate the daily errors first. So first of all, because we choose K to be 5, so we would skip all these columns by 5 days so that we have the same time frame for comparison among the four models. So I just type in the hyphen. For the naive model, the daily error will be calculated as the following: equals absolute value, so that we can take out all the negative signs, and we take the actual value, subtract the forecast value, and divide it by the actual value. So it says here, on that day, the difference between the actual and the forecast values is 0.75 percentage point of the actual value. And with that, you just drag it out or double click so that the whole column will be done. So we will do very similarly to the SMA error. So we would type it as equals absolute value. We take the actual value minus the forecast value by the SMA model. Please pay attention, right? We already move to the right hand side by one model, or that's why we have to move the reference here by one column, and divided by the actual value. So we always compare with the actual value. And then we have the percentages. If it doesn't show up as a percentage, then you would click on the number format and then click on the percentage. And to be a little bit precise, we would like to show 5 decimal places. So I would click on that button right here, right? So this button will increase the number of places shown. Or if you like to decrease it, then you click on that. But I would like to keep 5, so I click on this. Okay, and we just double click, then the all the numbers will be filled in. And for the SES model, we would calculate the daily errors as the following: equals absolute value, and we take the actual value minus the forecast value by the SES model, right? And divided by the actual value. And we just double click, then we have all of the numbers. And finally, for the daily errors by the DES model, we will type it in equals absolute value, and then we take the actual value. It has to be on the same day, so minus the forecast value by the DES model. So divided by the actual value, because we would like to calculate the percentage or the relative difference, right? So we hit enter, then we have the daily error by the DES model, and you just double click, then the whole column will be completed. But all of these are the daily errors. We would need to calculate the average error over the time period, right? So for the naive model, you will type it in as equal average, and then you highlight all the numbers down here. So with that, we already have the map of the naive model. You can manually calculate the error for the SMA model as the following: equals average, and you highlight all the numbers down here, right? Make sure that we have all of the numbers covered in the highlight area, and then we just hit enter, then we have the average error by the SMA error. So by now, right, we see that the naive error makes an average error of 0.56 percentage point relative to the actual value, and the SMA is 0.70 percentage point relative to the actual value, right? To make it quick, you can just drag it across like this for the SES average error, and just drag it more to have the average error by the DES model, right? So we can judge which model is the best based on the 4 numbers down here. The last thing that we need to do in this Excel template is to draw these 2 graphs. Basically, they are the same. They just show the actual values going up and down over time together with the forecast values by the four models, right? The only difference between these two graphs is if you look at the horizontal axis, in the first graph, we see the days, right? So we skip the first 5 days. So the graph here shows from day 6, 7, 8, all the way to the last days in the time window. And in the second graph, instead of the days, we show the actual dates, right? So we start from that's July the 8th all the way to the end of the time window. And in this picture, right, you can see the legends for all of the lines so that you can identify which one is which. So let's start from scratch. Let's pretend that we don't have the graph yet. I will delete them for now. To draw the chart, you will need to highlight the data that we need to draw. So I would go from the labels all the way down to the bottom of the columns. And you will need to go to insert at the top panel, click on the chart button, the line option with markers. So we need the markers so that we can identify which line is which, right? So when you click on that, then you have the basic chart. We will have to do some more work with this chart. So first of all, I would like to cut and paste it somewhere else in the workspace so that I do not clutter the view. So I would do Control X to cut it, move my cursor to a totally clear area, and then Control V to paste it. The next thing is we will extend it so that we can see more details in it. And by now you see here, because we skipped the first 5 days, so it looks very weird like this, right? So in that case, we would need to go back to the reference. We will need to click on the chart first and go back to the reference and fix it. So we need to skip the first 5 days. I will need to move the reference down here, right? So that at the end, the chart comes out right. And you can type in the correct chart title. For example, in this case, it's going to be the forecast, the Dow Jones Industrial Average. Or for your case, you will need to type in the correct company stock code. And besides that, you will need to fix the horizontal axis labels, right? Because we skip the first 5 days, so this number has to be going from 6 all the way to the end. For the dates, you also have to copy this chart. I would Control C to copy it. I move the cursor down here to Control V, right? And then you would need to fix the horizontal axis labels to be the dates. So either in Windows or in Mac, you would need to right click, and then there will be some options for you to fix the labels of the horizontal axis. So thank you for watching.